Well, I guess now we'll be looking at the notes at this rate. Okay, we're back. It's working for the moment, right? We'll see what happens. Okay, now, find the eighth term of the expansion, f plus s to the 12. So what do you think? Do we need to do the whole problem here? No, there's definitely got to be shortcuts, right? So, once you get into this and see it, I don't think you'll have to do what I'm going to do, but I'm going to think we want the eighth term, right? 1, 2, 3, 4, 5, 6, 7, 8. So what's the first term going to have? It's going to have f to the 12th power, yes? The second term is going to be f to the 11th. Then f to the 10th, f to the 9th, f to the 8th, f to the 7th, f to the 6th, f to the 5th. So I need the term that has f to the 5th. It's also going to have s to what power? The 7th, because 5 plus 7 is 12. Okay? So, since we need the 8th term there, I don't know exactly how you want to remember that, but you can think about like the s to the 7th is 1 less than the 8th. The 8th, 7 is 1 less than 8. Okay. We said we're looking at f to the 5th, s to the 7th. Additionally, if you look in the book, what they would say is it's f to the 12 minus 7, s to the 7th. And the reason here is you're using the 7s, which means we need the 8th term, it's 1 less than the 7. We need the 8th term. 7 is 1 less than 8 is what I'm trying to say. Really tongue tied on that one, aren't I? The way it's going to look like, yeah, you make no sense. Okay. So, now, what's my coefficient I need out front? The top will be 12 factorial. What about my denominators? 5 factorial, 7 factorial. Mm-hmm. Now, if you're asked to find this term, please don't just leave us at. Do you remember how to do factorials on your calculator? If I set up a fraction bar, I can do 12, and it's in one of my alpha menus. Alpha F2, which is window. So you can just do 12 factorial, 5 factorial, 7 factorial. Not that you can't count it out, or you couldn't type it out. Not that you couldn't work it out. It's doable. And just type as a review. You can use a calculator to do it. Final answer of 792, f to the 5th, s to the 7th. Are we okay with that one? Okay. Got one last one here. Be careful is my warning. Okay, so first of all, we want the 10th term. Okay, we want the shortcuts for the 8th term. We did 12 minus 7, and 7 was 1 less than 8. What if we want the 10th term here? Okay, looking at this one's going to be y to the 9th, which that means this other one is going to be 15 minus 9, right? So if we think about what is that first term is 2x to the 3rd, and we're going to do 15 minus 9. That's kind of, you know, what do you think? 15 minus 9? Or, as Daryl pointed out, he said it was the y to the 9. Now, what makes this one more complicated? It's no longer just f and s, is it? Okay? So, think this through. What kind of coefficient am I going to need? 15 factorial over 6 factorial, 9 factorial. Notice, I didn't just say x to the 15 minus 9, it's what? That whole term, which is 2x to the 3rd. And it's going to be raised to the 6th. 15 minus 9 is 6. What kind of y is that in the last term? So it's negative y to the 9. Okay. So, do you have 15 factorial over 6 factorial, 9 factorial? That's right. Yep. 5,005 for that one. What about 2x to the 3rd raised to the 6th? Okay, so notice he said 2 to the 6th times x to the 18. Because that 6 has to go on both the 2 and x to the 3rd. What is 2 to the 6th? 64. X to the 18. What about negative y to the 9th? What is a negative raised to the 9th power? Still negative, yes. So I'm going to say negative y to the 9th. Put that all in one term, all in one answer. Did you get it multiplied out? I got negative. 5,005 times 64 is 320, 320. X to the 18th, y to the 9th. So negative 320,320, x to the 18th, y to the 9th. Curiosity, have you seen any form of binomial expansion before? Yeah. Somewhere? But now having to go further with it. Well, somewhere along the line. I know it came up in the Algebra 2 because it comes up right before Christmas. And there's years where I've done it and said, okay, you guys can do this for extra credit, or, you know, there's years where I just haven't touched it, there's years where I've done it very quickly, it just kind of varies. So what did I do 2 years ago when I had you guys? I don't remember. So, okay, the other half of our lesson is recognizing the equations of conic sections. Okay, so first of all, right there, general equation of a conic section, you had this last year, ax squared plus bxy plus cy squared plus dx plus dy plus f equals 0, where a, b, c, d, e, and f are real numbers. Okay, there was something last year, I remember that in the pre-cal we talked about you can use the discriminant, b squared minus 4ac, and that can help you determine which kind of conic it is. Okay, Now, some ways to just recognize conics when they're in this random form as you look below. Okay? I mean, it's officially standard form, but it appears kind of a general form. If it's a parabola, okay, think about it. When you think parabola, you think y equals x squared, yes? So notice, there's an x squared, not a y squared. If it's a sideways parabola, it's x equals y squared. So if it's a parabola, x squared or y squared, not both. Okay? If it's a circle, x squared and y squared are both there. They're both the same sign and the same coefficient in front of them. Okay? So they both have to be, say, 9x squared and 9y squared. If it's an ellipse, just like a circle, both x squared, y squared, both the same sign, but this time, different coefficients, because ellipse is like an oval, right? And so by having different coefficients, it makes different lengths. And hyperbola, the difference with hyperbola is they are opposite sides. So there's x squared, y squared, one's positive, one's negative. And that's what's going to make the ellipse, which was like this, it goes out now, right? Okay, so I don't know that we're going to go through all of these, but indicate whether each equation is the equation of an ellipse, hyperbola, a circle, or a parabola. And then write them in standard form. Standard form is the form where you have it equaling 1. And so you can, that's what we learned last year. Okay, so look at it. First of all, is it an ellipse, hyperbola, circle, or parabola? What? Ellipse. X squared and y squared are both there. They're both positive, but they're opposite sides. So without doing any work, I know that this is going to graph into an ellipse. Now, let's write this in standard form. Standard form of the ellipse is the idea of x squared over a number plus y squared over a number equals 1. But that x squared and y squared have plus and minuses that help you determine my vertex. Okay, so like we would have seen it, okay, written in your pre-calc would have said x minus h, quantity squared over a squared, plus y minus k, quantity squared over b squared equals 1. That was what our standard form was. Okay, so, I guess we don't remember a whole lot of that, but let me give you some guidelines then. Let's prove it. Well, the x's together, the y's together, and then any constants on the other side of the equal sign. So as I group this, in terms of x's, we have what? 4x squared plus 40x. I tend to leave a gap. And then what do we have in the way of y's? 36y squared minus 288y. And leave another gap. Equals, what's my constant that has to move over? If it's plus 532, we're going to subtract it and make it minus 532. Okay, are you okay with my rearranging? The gaps I left should be a big hint. What do we have to do here? What? Okay, we're going to factor something out of it, and then we're going to complete the square. Yep. Now, the key is, in order to complete the square, do we have this 436 here? No, because remember, in order to complete the square, it has to be 1x squared plus bx. So on this first one, x squared, we're going to factor out a 4. Then I have x squared plus 10x. Leave a gap, into parentheses. We'll come back into that gap in here in a moment. Plus, similar thing for the y squares, except this time we're factoring out what? 36. Y squared minus 288 divided by 36 appears to be 8y. Leave a gap. Equals negative 532. Okay, that part's familiar, right? Okay, before I go on, we're going to complete the square here. X squared plus 10x plus what? B over 2 squared? Half of b is squared. So b is 10. 10 divided by 2 is 5. 5 squared is 25. So I'm going to add 25 there. If we add 25 on the left, we're going to add, quote, 25 on the right, but it's not just a 25, it's a 4 times 25. So I'm going to add 4 times 25, or yes, as Logan said, 100. And I don't care if you write 4 times 25 or if you write 100. I write 4 times 25, that way you go back and look at my notes, you say, where the heck did 100 come from? Okay, complete the square of the y's. Half of b in squared. Plus 16. So negative 8 divided by 2 is negative 4. Negative 4 squared is plus 16. If you add 16 on the left, you're adding 16 times 36 on the right. And 16 times 36, 576. Okay. I'm going to leave the 4 out front, and we're going to factor. X squared plus 10x plus 25 factors into x plus 5 squared. The square root of x squared is x. The square root of 25 is 5, keeping that little sign. Plus 36. And then I'm factoring by y's. So the square root of y squared is 5. Square root of 16. Or my middle sign is a minus those. We're going to say minus 4, what multiplies by 16 adds to be negative 8. Equals 144, he says. Negative 532 plus 100 plus 576 is 144. Almost there. If this ends in standard form, my equation has to equal 1. How do we make that 144 become a 1? You divide by 144. If you divide the right by 144, we're going to divide both pieces on the left by 144. Clean it up and we're there. So 4 over 144. Basically, what is 144 divided by 4? Put that response in the denominator. So I have x plus 5, quantity squared over 36. Because 4 over 144 reduces to 1 over 36, or as I said, 144 divided by 4 is 36. Plus, what about 36 over 144? What's that equal enough to? Y is a y minus 4 squared over 4, and it equals 1. Does that sound instantaneous but familiar? We did it last year. Good. Okay, because what this is this would be an ellipse centered at negative 5, 4. As a, what's the vocabulary word there? I don't remember. I don't know, it goes 6 out on the x direction and 2 out on the y direction. Can't remember what that word is. Not a radius, but whatever that word is. Maybe it's vertices. I don't remember. My mind's blanking right now. Okay. B. Without doing any work, what is this? Minor and major axis? It might be. I'm trying to remember if that's either the ellipse or the hyperbola. Yeah, that's from conics because it's either there we go right there. Hyperbolas. It is because hyperbolas has transverse axis and conjugate axis. So the ellipse. So the ellipse, the major axis, and minor axis was the whole thing. Vertex is how far you go out on the major axis. The minor axis doesn't really have a name for how far you go out. So okay. B. What is B? Is it a parabola, circle, ellipse, or hyperbola? Hyperbola? Because there's 9x squared minus 4y squared, they're both there, but they're opposite signs. So it is a hyperbola. Now, in my notes, I did not actually work that one all the way out. The process would be pretty much the same as what we just did. Okay? I do have written down over here what the final form is. So we're going to run out of time. We can't do all of these, I realize. So if you want the final answer to check yourself later, I have written down this x minus 3 squared over 16 minus y plus 2 squared over 36 equals 1. Is what I have that written down to be. I want to look at C. When you're ready. What is C? Parabola. Because there is, there's only the y squared, there's no x squared. So, we're going to work the parabola out because as much as ellipses and hyperbolas have the same technique, parabolas have a different technique because their standard form looks different. So here, what I would say on this one is you want whichever has your square. So in this case, it's a y squared, right? I want all my y terms on one side, everything else on the other side. Okay, if x had a squared, I want all my x terms together, everything else on the other side. Now, notice this y squared is a negative. It's probably going to be better to work with a positive y squared. So I think in my brain, I'm going to move my y's to the right, even though I'm going to write them on the left. Am I confusing enough here? So if you add the y squared over and subtract 4y, that is a positive 4y, positive y squared minus 4y equals, and then move those over there, the x minus 3 stayed. So it's x minus 3. I left the gap. Okay? Because again, we're trying to get this so that you can look at it and know the vertex. So, since my y has a square, so we're going to complete the square. Good news is it's already a 1y squared, right? So what the value completes the square? 4. Negative 4 divided by 2 is negative 2 squared is plus 4. If I add 4 on the left, you actually just add a regular 4 on the right. Okay, back to the left and we're there. Y squared minus 4y plus 4, what does that factor into? Y minus 2 squared. Clean up the right, x plus 1. There's your standard form for the parabola. Correct. You wouldn't be able to with the parabola, just the one on the right necessarily. I mean, you could here, obviously, but. Okay, so, and then the idea here is that this parabola has a vertex at negative 1, no. Negative 1 or positive 1? And positive 2. Am I blanking there? I think it's actually just positive 1, positive 2. So I'm going to have to double check that now. Nice. Let's go in for that one. And D, what is D? A circle? There's x squared and y squared, and they have the same coefficients. This circle, because it's not 0, 0, 0, would work out similar to an ellipse or a hyperbola. I'm going to tell you the answer to this one as well, and that it is x minus 4 squared over 81 plus y plus 3 squared over 81 equals 1. I was writing where you guys couldn't see. Okay, what's the last one? An ellipse again? Okay, so this one is an ellipse. It's x squared and y squared with different values. They're both positive. We have time. I'm going to work this one out. I can do it 10 minutes if it goes right in the homework. But. Okay, let's work this one out real quick just because there's a couple of issues I want to mention here. Okay, so do you remember how I did this? Form the like pieces, yes? X's with x's, y's with y's. What do we have in the way of x's? Just x squared. I don't have a regular x term? No. So I said I'll include a gap. I won't have to complete the square there. Plus y's we have 36y squared minus 288y. We'll have to have a gap there eventually. And what do we have in the way of numbers? Yeah, subtract over 532 and subtract over 40. Okay. Good news is x squared just gets to carry down as x squared. Nothing fancy there. What about the y's? I have to complete the square, so first step I have to do is factor out that coefficient, so factor out 36, so then it's y squared minus 288 divided by 36, which happens to be 8y. Leave a gap in my parentheses. Equals negative 532 minus 40 is negative 572. And I started to, I didn't want to do that yet. Okay, what fills my gap here? 16, half of negative 8 squared. If I add 16 on the left, we add 16 on the right. No, we add 16 times 36, which just so happens to be 576 like it was up above. Okay, so we've got x squared plus 36 times, how's this factor? Y minus 4 quantity squared equals negative 572 plus 576 is going to be 4. Officially, for general or standard form, we need this to equal 1. So I'm going to divide by 4. Final answer. X squared over 4. Now, 36 divided by 4 is 9, but where's that 9 really end up? Officially, that 9 ends up here, up top, as opposed to in the denominator. Standard form doesn't allow anything up here. It has it in the denominator. So multiplying by what would be 9 is the same as dividing by what? 1/9. So I'm going to write this as y minus 4 squared divided by 1/9. Yeah. So yeah, it's one of those things where we normally say no fractions within fractions, but in standard form here, you're not allowed to have a coefficient on your x and y squared values up top. So we make it by a fraction. It's going to be a very skinny ellipse. Okay. I think if my recording went, we actually got the second half of that recording in. It looks like it was recording, so hopefully it uploads.